Good afternoon and welcome to this Electro Rent webinar on simplifying 5G assurance with Digital Twin. My name is Richard Martin, one of the members of the product management team at Electro Rent, and it's my pleasure to be your moderator today. This is one of Electro Rent's ongoing webinar series on the very topic of 5G, and today we are being joined and supported by our partners in Spirent, who are experts in network testing. Our speaker today is Horst Fellner, EMEA leader on 5G solutions from Spirent, who's going to take us through Spirent's innovative approach to simplifying 5G assurance. Should you have any questions during the presentation, please feel free to write them in the chat. I recommend tagging them to either myself directly or the organisers and panelists section, and then afterwards, during the Q&A section of this webinar, we will run through them with Horst to get you the answers you require. So if we're all ready, I will hand over to Horst now to begin the presentation. Over to you.
Thank you, Richard, and good afternoon, everybody. Presentation will go about 35-40 minutes, and at the end we will have then 10-15 minutes time to answer questions as much as possible. In case we are not able to answer all of them, we'll take them as action points and then we'll come back to you. So what I'm talking today about is, first of all, for those who are not very familiar with Spirent, what is Spirent doing in telecommunications? We'll move then from there to the 5G topic and thematic, talking a little bit about the market. What is the market? What are the expectations with the introduction of 5G? What are on the other side the challenges? And what's the reality? And then I will move on to Spirent's digital twin concept. We look then as well into the components of the digital twin, and as well give some practical case studies which we done with our customers in order to give you a better understanding what a digital twin is about. So Spirent is playing meanwhile for quite a long time in the test and measurement field. Then we moved as well into the service assurance area. So we have then the possibility to provide solutions and knowledge in the lab, but as well to take that knowledge into live network for live assurance. If we look at Spirent's portfolio, you will notice that Spirent plays in lots of areas. So starting from device testing and validation, we just need to imagine 5G is now introducing quite a lot of new devices. It will even be that way that you will have then different frequencies depending on what kind of country you are. We are talking as well about millimeter wave, which is completely away from the standard frequencies which have been used so far. From the wireless device, we move then towards connecting them into the network. So the X-Hall, there are different ways of connecting, obviously, devices, so either via fixed line, either via mobile networks, which might be a wireless technology like 3G, 4G, 5G, might be Wi-Fi, might as well be satellite. Moving then on into the infrastructure area, so everything which has to do with the backbone, where we see switches and route high-speed traffic, and moving then afterwards further into the application area where we have solutions to test servers or infrastructures needed to support applications. For example, let's say as an example, there might be email server or firewall or whatever. All this to test the infrastructure. Then we have on top, obviously, as well end-to-end services. As I mentioned, moving some of the services from lab to live. So the active service assurance part we are serving. And we have as well solutions for positioning, timing, and navigation. So Spirent plays in a very wide area. We have lots of products. And if we look a little bit closer what we are doing in 5G, we will see that we have quite a lot of products which can be used either for testing a certain area or infrastructure or devices, services, and so on. What we as well have and what we're as well pushing quite a lot is the automation part of testing. So moving into the virtual environment, we see more and more of needs for continuous testing, DevOps as well. So you just need to imagine, you move your whole infrastructure into the virtual environment. And we see then there that new software loads are released very often, once, even twice per month. You have then, let's say, 20 different functions or network elements, server, however you call it, each getting quite often new software loads. You will need to constantly make sure that applying a certain software load on a certain network part or device will not impact the whole ecosystem. So this continuous testing is as well a very important area which we are addressing. And as I mentioned, in terms of concept, what we have as well is using the lab to develop new services, to introduce new network equipment and elements, taking them from the lab, launching them into the live network, and from there making sure that the services which be launched can be operated properly. And this is a constant validation, as I mentioned, from lab to live and then back to lab if you want, for example, to change services or applications and so on to optimize. So it's a constant life cycle of services of network elements which we are serving with Spirent. And I will show a little bit later on as well how and why actually we developed the digital twin based on the different products which we have here. I will not go at the moment into deep, they will come a little bit later. If we look where Spirent is focusing, this is now only the 5G area. We start with the radio side. So the radio is one of the most important areas in 5G. As I mentioned, there are the new concepts there, new frequencies. So we have, first of all, the sub-6 gigahertz, which is the classical commercial frequencies used for public communication. We have then the millimeter wave, which are frequencies starting at 24.5 gigahertz, going even further. These are frequencies which are used for really high bandwidth, less for movement. In order to achieve the high bandwidths which been promoted by 5G, obviously it will require to have multiple antennas aggregating traffic, so in each direction. So MIMO concept. You will then have as well the possibility to have antennas or so-called antenna arrays, where you have lots and lots of antennas on one panel sitting close to each other. And in order to optimize the output, you will use beamforming, which means that the antenna is intelligent and it's sending out the signal to your phone only in your direction and try not to interfere with the antenna which is next to it, sending the signal somewhere else. And once you are moving as well and are served by the same panel or antenna, obviously you might as well, the signal might as well move between different antennas and serving you continuously. So the radio is as well very important, as I mentioned. Then we have the next area, which is the 5G core. On the 5G core, we see, first of all, obviously a separation of the control and user plane. that allows the carriers or the customers to simply adapt better their networks according to the traffic. So let's say you have lots of IoT devices which are doing only signaling. In this case, you might simply increase the size or the capacity of the signaling part of the network by not touching the user plane part, and vice versa. It's simply depending what kind of application you have. So you might be way more flexible in differentiating and serving your customers. So a part of the new separation which we see, there are as well new concepts, new network nodes which been introduced. So we have the classical core, and then we have a so-called service-based architecture, which provides you only services when needed and connects as well when needed to whatever network element is required. Moving from there, obviously, then we see as well concepts like slicing, for example, which is very comparable to a VLAN on a fixed network side. So you will have a virtual network serving a certain type of customer or device type, which are requiring all similar parameters and KPIs. Slicing is very important. The edge side of it will obviously allow you to reduce and to offload as well some of the traffic. So all these are really new concepts which are coming hand in hand with the 5G core. Then moving on, we have the user experience on what Spirent is concentrating. Obviously, at the end of the day, the user experience is that what counts, because you as end user want to use your mobile in the best way, to have high bandwidth, to have a very good user experience, and that's something which needs as well, to be used and seen and as well monitored all the time. On the device side, we are validating the performance of devices. So 5G will require really high location accuracy. You just need to imagine you are in a smart factory and you have the robots which are moving parts. The accuracy of the location has obviously to be very, very high and very accurate. Talking about the smart factory, doing a proper handover, so moving from one cell to the other one, or even for commercial application is as well very important. And as well, performance of audio video quality of the end devices and of the network is very important. 5G, obviously, it is as well heavily based on virtualization of the functions. Well, actually, it's important as well to validate the infrastructure on which you are running all the services, to make sure that the service chains are working properly, are interacting as expected. You can do this life cycle management as well. I mentioned where you have this DevOps mode with lots of new software loads and making sure that it's constantly up and running everything and interworking properly. You have as well multi-vendors. Talk a little bit later about it as well. What's so interesting with 5G and with the multi-vendors, because there is as well some changes in this area. And then last and least, on what we are concentrating is on the X Hall. So on the front hall, we have this concept on the radio side where you are simply splitting the brain and the muscles of the radio by using, for example, CPRI and having then remote or serving remotely the radios in order to have a better performance and cost and pricing. Then you have the different aggregation networks where you're concentrating the traffic, and then you have the massive backhaul in the back where you have up to 400 gig pipes And all this is as well has to be as well obviously validated and make sure that it's able to serve 5G. So when we look actually at what 5G is actually promoting, what we should expect from 5G, there are mainly three pillars which can be directly connected to 5G. First of all is the enhanced mobile broadband. That's nothing else than high bandwidth, which you can use for augmented reality or virtual reality. You can use it for video download based on really high bandwidth. So this, the enhanced mobile broadband, is at the moment today the most actual use case for 5G. And we see there as well significant bandwidth differences between 5G and 4G. And the idea is that based on this higher bandwidth, you should see in the future more and more new services connected to the high broadband service. Then the second pillar which we have is massive IoT. Massive IoT is always related and connected to Industry 4.0, to smart cities, everything which has the tag smart in its name, where you are then able to connect lots and lots of devices. Each of the device can be totally different than other devices. So this is as well really important in order to move on with Industry 4.0 and all those smart concepts. And then we have the ultra reliable low latency pillar of 5G, which is as well really impacting industrial automation. It will as well allow automated driving, so it will allow vehicles to communicate between them, each other, and it will as well allow mission critical applications which are demanding very low latency, and they have to be always on and available, even if everything else fails. So looking actually at those three pillars, 5G is simply based around it. And what we see is that at the moment, we still don't have all the components properly in place. So there's lots of new things coming on. I mean, 5G started with release 15, now we are at release 16, 17, and so on. They will introduce more and more of the features which are belonging to those pillars here, and they then will enable as well new applications, new verticals, and so on. So if we look a little bit at the status of 5G, as I mentioned, we started with release 15. Release 16 is introduced right now, and then we have release 17 and so on. And if we look actually a little bit at the focus of those releases, we are seeing that, for example, release 15 introduced the concepts, 5G non-standalone or standalone. Then release 16 is starting now to introduce concepts and parameters and definitions for Industry 4.0, so high reliability, low latency, and some other stuffs which is coming later on with release 17 might be, for example, backhauling via satellites, non-terrestrial networks as communication. Obviously, one part of the big concept are the standards, the specs. The other one is what we need as well to see what are the service provider doing and how are they deploying the standards. And at the moment, what we see is that the focus is on 5G so-called non-standalone, which means that on the radio side, on the cell side, you have already 5G, but in the core, you are still using the LTE core. That's called a non-standalone. And the first service providers now start to move on and look and validate the standalone core. So this is actually the real full 5G core, which will allow as well lots of new verticals and applications. Then obviously the next one will be release 16 upgrade and so on, introducing the new concepts. Here it's mentioned slicing, moving on then to edge computing, and then at a certain point in time later on as well, trying to use other means of connecting to the backhaul than what we have today. And satellite is one example here. What is well interesting is that with 5G, we start as well to see lots of verticals, which are sometimes as well even competing with service providers. So for example, we have Industry 4.0. Industry 4.0 is pushing quite a lot to have so-called private networks. So you might then actually deploy an LTE or a 5G network, which is proprietary, which is closed, which is normally used inside a factory, and enabling then the factory as well, or in the factory, this smart concept where you have everything automated and so on. And obviously another vertical which is as well very interesting is automotive, where obviously at the end of the day what we want to achieve is an autonomous driving. We're still far away from there, but we start to see first hints of how this develops and moves on. What's as well different than in the past is that the 5G network is not so compact like before. So in the past, it was very clear you had an access network, a core network, data centers, and so on. Very strict, split it, and you could very easily differentiate. Nowadays, what you have, you might have simply a combination because everything goes towards virtualization. You might then, for example, move components from the core towards the access in order to have certain better performance optimization needs. You might then as well split the radio, where you have some components in a centralized place and the radios itself, which are only distributing the RF signals. They might be totally away. So there is actually a really big change in the whole network itself. And as well, if we look a little bit into the core and the radio side, we see there as well a transition from classical physical core equipment, which we always used in the past, to moving those functions one-to-one in a virtualized environment. And at the end of the day, the whole idea is to have this cloud native implemented, which means that you will be able then to provide so-called microservices and to implement only certain parts which are needed for your services or for your applications, and not the whole core. And on the radio side, we see as well big changes. I mean, those who are familiar, O-RAN is a good example here, where we started already to see that we have this distributed RAN, where we have the radios and the baseband to process it in different places. Then in order to get synergies, you will have a centralized baseband processing, so all the brain is in one place, and the radios, they are then somewhere away, might be even tens of kilometers eventually. And then moving forward to the virtualized, the full virtualized RAN, the open RAN or cloud RAN, where you might as well develop your own stack as you need for your applications. and all this on a common hardware. Moving on, we see then network slicing as well a very important piece of 5G, which are simply allowing you to take the physical network, slice it into small chunks, and each of those chunks or the slices, they can be configured and used in order to serve a very specific type of device, or in this case, you see here mission critical, it might be a robot. All the robots in a factory, they might have a certain requirement, obviously low latency, high reliability, then you might have other applications which are requiring only high throughput, or others which are requiring low packet loss. So what you can do here with the slicer, you can simply split your network as needed in order to better serve customer and user traffic types. So these are all the concepts, or some of the most important concepts and status of 5G. However, if we look a little bit further, we see that there are still lots of questions, and that is as well something very important. So maturity of 5G is still pretty far away from being or from already deploying all the features which they are promising. It's not even 1/20th or something like that. So there will be more and more features coming up. There is as well high pressure, obviously, on the players in the market to introduce new features or concepts based on the technology. But as I mentioned, so it's a little bit in a baby steps moving on. Then we have the hybrid network complexity, which means you will still have a 4G network, the public networks. There'll be lots of investment done on 4G that will not disappear. So we have at the moment this hybrid concept, 5G non-standalone, where you have 5G in the radio, where you have 4G in the core, and then the last one will be then actually the migration. So you will have, or you will see as well in the network, all these different concepts running in parallel and be used in different ways by different players and actors in the network. The customer perception, I think it's pretty clear. So you need to show the customer what are the benefits if actually he's signing a 5G contract. Bandwidth is fine, but bandwidth, that's not all. So it has to be more. So the idea is that you should be able to add to him additional new services and so on to make 5G way more interesting. What is then as well very important, obviously, is all those deployments. As I mentioned in the past, you had a pretty rigid network. Now this is changing. It's way more dynamic. You have as well the possibility, for example, let's say you have a concert or whatever, or football match, only for that match to move parts of the infrastructure as close as possible to the stadium. After the event finishes, then actually you can take it away, and you have to make sure that all this moving back and forth works properly and it's not impacting the whole network. In the past, it was as well pretty clear. You had the big vendors. Now we see more and more of those vendors or smaller vendors coming into the game, or vendors actually who are providing only a certain application or a certain component and so on. So the boundaries between the players they are simply disappearing. And obviously, like with all technologies, mobile technologies as well, the security risks are here. So everybody talks about 5G security, but it's still not very clear, what exactly will be the impact of the security and how this will impact the whole 5G concept. So if we look now at the market challenges, what we see is that on one side, 5G will be introduced, or it's introduced way faster than before. On the other side, this is a little bit contrary to the complexity which is introducing to the constant new features and so on. So really, the challenge here is to accelerate deployment and introduction of 5G. Obviously, what we see as well is that lots of players into the area are simply missing the possibilities to validate what they are doing. And what we see as well is that in Europe, EMEA, there is as well a big need for money, for funding. There are, for example, governments, they are as well playing into this area by providing funding. So, some of our customers, they are really looking, obviously, to attract investment by providing, some means in order to develop and to provide help in development in 5G. And therefore, we came up with our own Spirent 5G digital twin. So the challenge which we see as well is that, for example, let's take automotive, right? In order to be able to introduce a certain new feature or whatever, you will need to do lots and lots of driving, of real driving. That's simply not possible. And the other way of avoiding it is to have actually a mix between simulation, emulation in the lab, and as well afterwards combined with real driving. So same applies as well for manufacturing, or talking about security and so on. So some of the things you cannot do only in a live network, and therefore the need for a digital twin. So the digital twin which we are offering is digital twin per se is nothing new. Digital twins are well established and known in the industry. What's different is the way how actually we are using the digital twin. So far, the digital twin, it's mainly actually a theoretical model which you have some data, you take those together, you apply algorithms to it, and then you have an output. And with that output, you can do a prediction. Normally, for example, you have this engine, you have measurements how an engine behaves over years, and then actually you can predict, when it's breaking, or when it needs replacement. So what Spirent is doing for the communication side is our digital twin is actually a digital clone. So we are taking a real 5G network or 4G network, doesn't matter, and migrate it in the lab by providing every single component like in a real network. So there is, for example, an AMF, an SMF, an UPF. And this way, we are enabling our customers to do their validation, their testing, their proof of concept by providing them an agnostic 5G network. And on top of that, we can as well obviously enhance it in order to support as well negative scenarios. So what would happen, for example, if you have an application which is time sensitive, and in the network there is quite a lot of delay inserted? When is this application breaking, as an example? And if we look at the way how we do it, we have this full network, which is using either a UE simulator or real UEs you can use. They can be either communicating via antennas towards the cell, or we can as well use a channel emulator for conducted communication. Conducted communication would mainly replicate RF, but in a lab, it has the advantage that you are not dependent of certain conditions which you have in the RF side. We have then GNBs for 5G, we have for eNodeBs Bs for 4G, so the 5G non-standalone concept or handover concept, fallback concepts. can as well be served. And then we have 5G, 4G core, and that would allow you to send traffic. And with this concept, depending how much you're deploying of the network, you have the possibility and you have the means to build your own agnostic 5G network, which is anyways 3GPP compliant. So at any point in time, it can be interconnected with commercial components or parts. And this allow the digital twin to be used in multiple use cases. So we have lots of examples with government and universities. Industry 4.0, we have virtual mobile network operators or real operators. We have as well the car industry, which can use this concept. So mainly everybody who needs a test bed can use the concept. And it is as well, as I mentioned, it is compliant with 3GPP, and at any point in time can as well interwork with other components. So you don't need to deploy all of it. You can deploy, if you want, only parts. It has as well a significant flexibility which you can introduce, because if you're using a commercial component, you will not be able, for example, to build negative scenarios. It is at your own usage. You can configure it as you want. You can do with it what you want. And if we look at some of the components which we are using, so for example, we have on the device side, we have the possibility to use the digital twin in order to validate devices, to validate chipsets for their location, for their services of voice, video, and data. We have then as well the possibility on the other side to move on and to validate the user experience. So that's actually what a customer really sees, which can be done in the lab. You can as well use it in the live network. So for example, one use case here is where a customer is using this solution in trains and even in planes to see how the connectivity to certain servers are working, how stable it is, how the application can be transported. We have then the possibility to provide satellite emulators. So this is as well something very interesting and important. To emulate in the lab, for example, moving devices and correlate then location accuracy. We can as well use the whole digital twin to run security assessments, for example, for devices, for IoT, to play hacker, so to insert in the middle between the interfaces, and play there and validate the vulnerability and penetration testing do as well. On the network side, I mentioned you can as well avoid the physical connectivity on the RF. So not only RF connectivity, but conduct it with a channel emulator, so-called Vertex here, which would allow you to validate, how good the mobiles or devices are working. How good actually is the bandwidth. What would happen if, for example, you're using multiple antennas with lots of delays or different delays. So MIMO, how good it's working, beamforming. You can as well add some additional software on it, channel modeling. So you have then mobiles communicating to each other, between each other, and this channel modeling would then emulate increasing distance or the changing conditions and how good actually all this works. Then we have for the core emulators, we have the possibility to emulate each of the network components on elements on individual base, as I mentioned. allowing you to move them if you want. So, for example, validating edge computing scenarios and or slicing and so on, validate capacity, performance. We have then on the backhaul side and on the cloud side the possibility to validate data center infrastructure, to validate the NFVI, the network virtualization, and make sure that, you know, if you want to move certain functions into a virtual environment, that environment is able to handle it. On the one side, on the other side as well, obviously very important is to validate the bandwidth of the links. So are you able to support, let's say, 400 gig or X times 400 gig in order to send all the data to the network? Automation or lab as a service is as well an important part, which we are serving, starting from really automating and steering only our tools, moving on to the next level, which would include as well devices under test, would as well include up to the whole lab, where you can then assign resources. You can as well use repositories for tests and so on, and run them all in automated environments, from very simple to very complicated and sophisticated automation. And we can as well run all this as a lab as a service. So looking now a little bit why we need a digital twin, you know, we simply see that it gives you an easy access to a 5G network. This network is under your control. It's flexible. It allows you to do repeatable tests. It's way more efficient than compared to providing same functionality or features, if possible, other commercial ways. It allows our customers to accelerate research and as well time to market for their products or services. It empowers as well to build ecosystems, what we see as well. And this is as well very important, very attractive to our people. We can as well build, you know, based on the digital twin, for example, security modeling. You can as well validate services. There's quite a lot of scenarios which actually can be done with the digital twin. And now I'm moving to the last part, which is, you know, some of the use cases of the digital twin, which we already have in place. So one of it is one use case is campus networks. Campus networks is something which is very fancy. Meanwhile, as I mentioned, focus comes from Industry 4.0, and in this case here, the requirement being to provide a test bed for this campus. And on the test bed, you will have then different verticals which are using it, you know, like smart buildings, like surveillance, and so on. You even have a car track here with blue line, which where you have cars which are actually then sending data via the network to the data center. Support here as well for multiple type of devices. As I mentioned, each of the device or verticals, they would need to have their own parameters and settings. And therefore, what we provided the replica of a network. So we provided a core. In the core, which is supporting multiple devices, multiple users in parallel, you have then as well different kind of settings for doing slicing, so allowing actually each of the verticals to have their own parameters, and then connect all those different kind of devices to the data centers. Another example of what we've done is we have commercial customers. So the first one, this campus network, was more on the research side. So this one is commercial. And what actually been tested here is the interworking between different vendors. So AMF, SMF, they've been coming actually from as well from from different vendors. They are virtualized. And we had then to generate high amounts of users, high amount of user traffic, and then validate how good and how stable the components, the commercial components are. But with as well a kind of vendor validation. At the same time, because actually all this been virtual, what we done before testing the virtual functions, we as well had to validate the infrastructure below the data center. So if the data center is generally able to support all those virtualized functions at maximum performance. Another research project which we done was in automotive. So together with the University of Warwick, they are working in CAV. So what we done, we have provided them the digital twin as an enabler to build their own 5G network, connect to it cars, and in the cars they have the modems, and the modems then actually are sending the data to a data center. Same time, because 5G is requiring as well location and timing and positioning, we had as well to provide satellite emulations to the car. So there being the satellite emulators simulating a GPS network on top of it, and then the car is virtually moving in the theater, as you can see here. And how all this been looking like? So you had actually the car in the theater, and connected to it, you had then the satellite emulation. You had then the cell and the 5G core, 4G as well later on, and then sending data over to the data center for validation. So looking in summary to where we can deploy the digital twin and what kind of benefits we see is, first of all, we are simplifying. You can use it to simplify the network complexity. So to understand how you can do a 5G network, what makes sense, what make not sense, how you can optimize it, to do the baseline, the benchmarking of certain components or applications, and as well to validate them before you're simply using them in a network. On the research side as well, you can use the digital twin to understand all those new concepts, smart factories. You can assess, you can do recommendations. You can obviously as well optimize everything. And what is as well very interesting is you can as well take the kind of tests which you are running into the lab and use those as well in live networks. So from lab to live, doing continuous and automated and agile testing. And the advantage which you have is that the same kind of test concepts or even same kind of tests, to run them in a live network at 24/7, obviously low scale, and make sure that the network is able to keep certain KPIs. So for example, you can run in a certain slice 24/7. Every few minutes you can run a low amount of calls and measure certain KPIs to make sure that that slice is able to handle all the performance which is needed and the KPIs. So from Spirent as well, the benefit what we are using, and this is now the last slide, moving as well towards the end. We have products in 5G for testing and as well for live network. On top of that, we can as well, we are moving already further to provide solutions. So to add a certain value to the products by combining them and offering new solutions and offering, for example, new services which not been here before. And what we are obviously as well doing, because we have all the experience, we have people who are knowledgeable, who understand the technology, and they are able to provide as well competent advisory and trusted advisors to our customers. And with this one, I will finish. So we should have 10 more minutes for going to potential questions, if any. And thank you so far for listening. Richard, do we have any questions?
Hi, Horst. Yes, we've got a couple of quick ones which should be quite interesting that we've had through. First one that's come through is, how close is the digital twin to a real viable commercial network? Are there any limitations in there? Are there things that the twin can't do, or is it just genuinely a digital version of all the hardware that's out there?
Right. So, well, our products, which are as well inside the digital twin, they're as well used by commercial partners. So as such, they're used for validating their products. So they have to be through GPP compliant. Obviously, they are not carrier grade as with competitors, but a part of that, actually, we are implementing all the 3GPP standards. We are implementing all the regular updates which are coming with 5G or 4G or whatever. As I said, as a limitation, I would simply say the carrier grade apart. What is positive, what you will not be able to have in a carrier grade network is you can as well spice it up here, the digital twin, with other components which are not mentioned here, which can be used for building negative scenarios. So, if, for example, as I mentioned, you want to see when is a certain application breaking, we have means to impact the traffic. So, for example, latency would be added, or packet drops, and so on. Any other question?
And there is one other one, yeah. Obviously, you've mentioned that 3GPP is regularly updating the base of its specifications. I assume from that point that Spirent is obviously keeping on top of these, and the digital twin is constantly updated at the same rate that an actual network would be to allow it to test the latest and greatest.
That's correct. Yes, that's exactly what we are doing. As I mentioned, customers are using us as well to validate their own development. So as such, we need to make sure that we are on top and introducing as fast as possible the spec updates. Yes. Okay.
Wonderful. Well, then I think we've reached the end of our list of questions on this one. So first of all, I'd like to thank obviously Horst Fellner for presenting today, as well as answering all the questions on Spirent solutions that have come through. And I hope that all of you attending have found this both informative and interesting. Should you have any further questions about this or any other 5G testing or assurance topics, we at Electro will be happy to receive them and work with our partners such as Spirent to help you find solutions for your testing needs. There's obviously on screen now a contact email and telephone number if needed. All of the solutions that have been shown today are accessible via Electro Rent, via both a short-term rental model or via financial solutions to allow you to change your CapEx plans and allow you to buy at a later date. Should this testing be something that is interesting to you or may end up in your future plans, feel free to contact us. We'd be happy to facilitate a discussion between you, ourselves and Spirent to make sure that we can provide you with the correct solution to all the challenges you face with the new 5G world. There will be more webinars coming soon, so please keep an eye on our social media feeds and website to see what is upcoming, and please feel free to register all with these sessions that would be of interest to you. Once again, thank you all for attending, and have a great rest of your day. Thank you very much.
From my side. Thank you, and have a nice day. Thanks. Bye-bye.